Hello and welcome to the CodeMaven channel and CodeMaven meetup group. My name is Gabor Sabo. I teach Python. I'll help companies with Python and Rust. And I also organize these meetings, these events online, because I think it's a very useful platform to share knowledge. And I'm really happy that Nikita agreed to give this presentation. Hello, Nikita.
Hi, nice to meet you all.
And sorry, and those people who are present, thank you for joining the meeting. You can freely ask questions in the chat. And if you're watching the video on YouTube, then please like the video and follow the channel and join our meetup group, so you will be notified when we have the new meetings, new events. So with that said, Nikita, it's your turn. Please introduce yourself and give your presentation.
Yep, sure. I'll start sharing my screen and then probably I'll start exploring. 1 second. Okay. Hi everyone, once again. My name is Nikita and I'm a software developer at Checkpoint Company right now. And today I want to talk about one of the things I had in my previous experience when we decided to switch from RDS to DynamoDB for our users table, and how we thought about it, what was the overall architecture, and how we build a microservice with Python FastAPI that helped us to make this switch. We will cover different topics, like we will talk about general differences about RDS and DynamoDB, and like I will highlight some main things that might make you think why to switch from one database to another, or will help to understand our motivation behind it. And we will go over the architecture of the microservice that we built, and I will give you some examples over there, and we can talk about it in more details if you want. So let's have a quick overview. I don't know everyone familiar with the DynamoDB or RDS, what is the differences, but like main one, like DynamoDB is a key value like NoSQL database. It's fully managed by AWS, and it's very good for applications with like low latency, with like flexible data models. And opposite RDS is the SQL database, and we have like a predefined schemas, and it's also managed by AWS. But the difference between DynamoDB and RDS that for RDS you really have to invest more into like knowledge into setting up things over there. And for sure, if you have like complex queries, joins, and etc., RDS is better for your solution. When you decide on like which database to use, you will probably look at several things like scalability, performance, availability. And here I present some basic stuff about differences like for each of them and DynamoDB and RDS. But overall saying, again, for scalability, we know that DynamoDB automatically scales horizontally, and that really helps to manage like a large amount of traffic without any interventions. At the same time, like RDS scales vertically, and it has to increase the instance size, and this increase it also takes time, and there might be some gaps in performance also because of that. And for performance, as for RDS, it really depends on the type of the instance you chose, the storage. Like as I said before, you really need to know what you are doing there and how you're setting it up, because if you won't do it like properly, you might have some slowness, or database won't be available, something will be down, and users won't be happy. And as for availability, we found out basically for ourselves, like say, big difference for DynamoDB. There is a thing like that you can activate that calls global tables. Like it's like a multi-region, multi-master write database solution. For RDS, it supports, and let's call it multi-AZ, multi-availability zones. it's replicate the data across different availability zones, but in the same region. And another thing that you will have to consider, it will be interesting for you, is like cost consideration. For is, let's say, dynamic pricing. In RDS, cost will increase as you scale vertically, like large instances, horizontally, like read replicas. Also, RDS also provides like on demand, but still, if you like chose the instance with a special, like, let's say, storage of, I don't remember exactly the batches there, but let's say 60 gigas, you will have to pay for 60 gigas even you use 20 of them. So efficient high-read handling. DynamoDB is really optimized for high-read scenarios, and it doesn't provide different replicas. Okay, it can like handle millions of requests per second with the architecture that AWS provides to us. And we all want to have, let's say, predictable cost and capacity modes. And because of that, into benefit of DynamoDB, DynamoDB offers two modes: provisioned capacity. When you set up the database, basically you have to say how many read and writes, like what is the bar, let's say, for them, for your database, and or you can use on demand that will automatically scale up your traffic and ensure you pay only for the usage. We had a situation when we worked on one online store, and we had a situation that we didn't predict because no one's following Super Bowl in the United States, but we just lost it, and the traffic went up, and the people tried to buy beer in the United States, order it online, and we didn't expect that. But thanks to the DynamoDB architecture, like scaled up automatically, and we were on the pretty good side. These are very general cost overviews, okay? I just wanted to give you some examples. Don't take it like strict that you have to calculate it like this. I just wanted to have you like basic understanding, okay? For RDS, you pay for instance cost and for the storage. Once again, the specification could be more complicated, but we're talking about basics. And for DynamoDB, you pay for write capacity units, read capacity units, and also for data storage. But regarding the storage, I wanted to give you some like more detailed calculations here. If you, for example, want to store 5 gigas, 10 gigas, 20 gigas, you will pay the same price for the storage all this time. Because, as I said before, you choose the storage type and you have to pay for it, even if you use less. Okay, at the same time, you see that for DynamoDB, this thing is dynamic, and it depends on the real story that you use. There are more things that I mentioned here. I'm not sure if you want to be overwhelmed right now. Let me know, but these are the very basic things that I wanted you to consider just to understand RDS DynamoDB. Yep. So we talked about different like database types, like SQL, non-SQL, specifically RDS. Actually didn't mention it, but I consider PostgreSQL if it's important, and DynamoDB. Now I want to talk about the actual problem that we had and the solution that we found out for ourselves. So the overall problem was that when the number of users, like the number of requests to the database scaled, like went up, we had spikes. Our RDS like didn't work well sometimes. So we decided that we need to do something more stable, and we started to consider different databases. And because we had previous experience with DynamoDB or another project we had, we decided that we want to build an architecture where all our clients will go to the DynamoDB through a user's microservice. But the problem is, another problem, is that today all of our users are stored in PostgreSQL. So how to manage it? Two different databases and like not just physically databases, I mean different types of databases. That's kind of challenge, okay? So these are very like, again, general overview of the solution, but on the left side, you see the clients. Each of them is like a client that it could be a backend client that wants to get data about the specific user, or to get all the users by some condition. And how we do it, we decided to implement several feature flags, including like that will tell us where we should read the data from, or where we want now to write the data to. And based on these feature flags, we are doing like get requests, or we're doing like put, post, or delete. We do all these iterations based on these feature flags. And this is the like PostgreSQL architecture, nothing like special here. And this is the user service. So we have the containers here, and we use Redis for caching and DynamoDB. Without additional details here, but I mean, I think it could be pretty clear what we are trying to do here. Let me know if you have any questions so far. I will be happy to answer them, because this scheme, if you have questions, I will be happy to answer them, just for you to be to make it more clear later. And except the fact that we want to transfer to DynamoDB, we need to have this transition period. So as you saw in the previous like scheme, we decided to implement the service like API that will handle all CRUD operations related to our DynamoDB. And we also need to transfer all users' data from RDS to DynamoDB. This was done, we wrote different scripts that basically can grab the data from the RDS, transform the data as we want, and to basically transfer this data to DynamoDB. And we also decided, as I mentioned in a previous slide, we decided that we want to have feature flags. The first feature flag, read user from DynamoDB. If it's true, we go to DynamoDB, the microservice in DynamoDB. If it's false, we go directly to the PostgreSQL, and read user to RDS and write user to RDS and to DynamoDB. And these are two flags that basically we need to support this period when we work with both databases. We tried to make this period as short as possible, to make some like tests on the QA, on staging, and then on production. We saw how it works in production, but once we saw that everything works like fine, when we don't have any requests from the customers, we don't have any bugs opening, so we closed write user to RDS. So the channel, let's go back for a second if I can. Yeah, basically this channel, this path was closed. So we just continued working directly with our user service. The read from DynamoDB was always true, and write to DynamoDB also true, write to RDS was false. So all this scheme started working only with this part, avoiding PostgreSQL. I wanted to show the client-side architecture. The client, as I mentioned before, like every service that wants to get information about the user, and just wanted to give some code examples and to explain what we just generally try to achieve there. We wrote like a model interface And the purpose of such interface is to be a handler for all calls to DynamoDB through the service. Okay, handle responses from the service, manage all the retries, manage all the caching, etc. So be the one that gets the data for the client from the service. It could like look like that. One of the functions that we could use, like get user by email. We initiate the user client with some parameters over here. One of the parameters that I really like to mention is the requester ID. I will explain later. I can explain it actually right now, because why we need it, basically for the login and for the tracking. If something falls down, I really like that we know which client made this request. And on the left side, the function itself, which uses the feature flag. The code could be optimized. Don't look at it like as a perfect one. Just wanted to make it as much clear and readable on one slide as possible. So if we want to get a user by email, we looking at this feature flag, and we basically want to have a request to DynamoDB service. This is a client link, and we want to make this API call. Else, we're going, as we did it before, we just go into PostgreSQL and getting data over there. This is the function get user from DynamoDB. I just made it a bit like more specific over here. We're setting up all the params that we want to get, and we're making API call to the route, and we're handling the response. You can handle it wherever you want. We at that moment in time decided that we want to return two values here. The first one is like represents the status if it's okay or not, and the second one is the response. So we can check if the request was okay or not. And this is actually the call API function that actually makes a request to the service. It has like some retries. You can set up whatever you want. And once again, you can make it better if you want. Logging, you can make here a request itself, and for sure error handling with logins also. And if any questions so far, let me know. And this is one of the examples how a client can make a GET request to the microservice that will then get a data from the DynamoDB. So let's have a look at one of the routes of the microservice itself. As we know, we decided to use a DynamoDB. First of all, you have to create this table. I just wanted to give you some quick overview of what is included. You see here some params, including like key schema that defines the primary key. Primary key could be also like a composite key of two, let's say, two fields. And this is what actually help us to get the data like quicker. We have different attribute definitions that describes the primary key fields, and we can also set up different global secondary indexes. One of them for me is like email index that allows us to search by email, also not only by ID, but you may have different indexes, not only one. About the routes, maybe it could be obvious for many of you, but actually I was surprised when it wasn't for some of like other developers when I talked to them. The basic service handles all the get, put, post, delete requests easily, like should do it, okay? But things that people are really missing, like what we want to update many users at once, what we want to create many users at once. someone called it. So when you talk about DynamoDB, when we talk about the cost consideration, it's much like better. Let's say you want to create 100 users, you have a reason for that. Let's say you don't go in a for loop and creating like one after another. You're sending the batch of 100 users, and basically this batch will be divided by two chunks by 25 records, and it will be like ready for requests. It will be done to DynamoDB, so it's much less. Okay,
There is a
and
question.
yep.
How did you convert the data model from relational to NoSQL?
Yeah, okay, that's a good one. Pretty easy actually. So since we know that SQL is like we have a strong structure, like a fixed structure, we know what to expect, and we basically created another dictionary for every of the user and transferred it. Like basically, we knew what is the scheme of the PostgreSQL. We receive the users, we transform that to like basic dictionary, and using the post method like with the bulk, created it in DynamoDB. That's it. No, not really. No magic over there, actually. As for the datetime object, maybe this is what maybe specifically interesting to you. We stored date as a string, so we can convert it. You can also store it in a milliseconds. What else we had over there? So we had Boolean Boolean fields, and nothing really special that can challenge you. Just converting an object that you're getting from PostgreSQL to the object that will be suitable for DynamoDB. Yeah. Did that answer your question, or I can be more specific, actually? I just don't see if it yes or no. Just sharing the screen.
Yes, he says.
Oh, okay. Cool. Yeah, I see here now. Yeah. So talked about obvious, not obvious things, and this is a service setup. I also tried to put many things on one screen. Can you see it? Because when I just showed it live, people struggle to see it. I just want to.
If you could enlarge a little bit the whole thing, that might be nice. I don't know if you can do that.
Doesn't look. One second. Doesn't look like it allows in this mode. And this doesn't help. Mm.
Yeah, why did you need, there's also another question in the meantime. Why did you need Redis if DynamoDB has great performance on reads?
Because it's also good for saving money actually, and Redis can be applied in a second. It's a good one because let's go over here. Okay, so we now saying that we are working like this. Okay, we are going from client to DynamoDB, and I mentioned Redis only here, but also I had, I think, to mention the Redis on this layer. So what's happening right now is that our client makes another API call to another service, which like every call, let's say, costs us something, and then we go to DynamoDB. It's Redis is not only about the speed; it's also about the money. costs reduction. And for example, here at this layer, if the client was created like not properly and many requests, you don't cache the requests, you don't cache the results, this client will make another request, and it can grow up dramatically, and you will get like a huge cost after that, after all. So Redis is the solution for that also. And using Redis for caching basically allows you, first of all, to decrease the load of the service, and as a result, to decrease the cost. So one of the reasons, which not everyone think about in the beginning, is like the cost reductions. Yep. Is that okay? Trying to. That answers the question?
I think you can just go. So you used, okay, I'm just reading out. So you used Redis or used AWS caching services?
Redis. We use Redis.
Yeah, okay.
Because we use it widely in all projects, and we are used to Redis. So using Redis.
I think you can go back to the code example.
Yeah. Okay. The first things that you will need for the service is like the setup is pretty easy. FastAPI, Redis, DynamoDB, and Pydantic. Even though we said that the DynamoDB is like we don't have to follow this strict schema, it's a very good practice to have one. I mean, in DynamoDB, when you create a record with a field like none, it won't be added. So you won't find it if you go to the UI, you won't have it. But when you get in the data, when you return the data, it's very good to have the model that you can use to serialize what you receive from DynamoDB, from the database. This will help like to the client to know what to expect, and avoid some unpredictable scenarios. So the model is always good, even if you work with a DynamoDB, with a key value database. You see here like one of the examples of how you can model data. There is a function that set user cache that sets a specific key value into the Redis with the like expiration time. So you can find and set exception log error, that every time that something falls down, you will see it later. We just throw a proper log. Sorry, I need to move the bar. Yeah, that will give you some details. I don't know why, but I also saw a lot of examples of people trying to avoid it in logs or forgetting adding logs. Like, I think it's a must. You have to show, like, to have it written somewhere. What was the error? And what I mentioned before is like requester ID. It's very important if you have many services or clients that work with the user's database, and that everything goes through the service, like a main point, all these cloud operations. You need to know who made the request, when. It's very good for analytics. You can use it for Grafana later on. You can use it to debug things. Only positive things from the logs that I see. And also, for sure, it can increase the costs for some reason, but still, you have to find a balance. Second. Yeah. This is one of the simple examples how you can get the user You can get it by ID, by email. You can specify which fields to project. It's like select in PostgreSQL when you do select email, like first name, last name, the same, and it will return you only these fields. The same you can do in DynamoDB. Basically calls projection attributes also. We're checking if there are ID or if there is ID or email provided. Basically, a very logical thing. If nothing of this is provided, you don't look for the user. Only if you don't have maybe a route that can do a conditional search. But here I decided to show like the basic one. With conditional, I mean, for example, in SQL, when you look for the user which with the name Nikita, all the users with the name Nikita. So you don't have ID or email, but anyway, you can do it the same thing over here, just didn't include it over here. This is the actual process. So before going to DynamoDB, we are checking the Redis cache. So we're checking the cache, and if there is nothing in cache, so we proceed to actual lookup at the table. So here is like users table is like let's say an agent that we initiated before that knows the function get item by key. And if we provide projection attributes and we say that please return us some specific fields, or we search by email. Once again, you can optimize this code as you wish, but again, this is just for example. And then in the end of the day, after we found out the user, if we found out the user, we cache it. In this specific example, I wanted to mention that we potentially may have 3 types of successful response over here. We may be in the situation, we may end up in a situation when we didn't find any users according to condition that we were like according to ID that was provided or email, and we return that like empty object here. Or if we provided projection attribute, we return the data as we received it from the DynamoDB. Or if we did find the user and didn't provide any projection attributes, here we want to serialize it. We, as I said, we have a model and we want to serialize the user. All the fields that we have inside the user will be patched as they are, like a key in its value, and those that are not will get like a default values. Normally, you put them as none because there is nothing. There is no reason to put something not relevant. Depends on the business thing, but yeah. And another thing that that is also important is just like error handling. We have different types of error handling. Please don't forget about it. Please use it. And even though it may look like overwhelmed, I find it sometimes much better to have it rather than avoiding it. And after that, something is crashing and everyone like is trying to understand what was the situation. You can handle it everything with a general exception, but if you are provided with the tools, why not to use it? My idea. Just wanted to sum up the service, what it's like intended for, and there are 2 things that you see here that I didn't mention up, but they are very important for the services like that. So the service idea is like handling DynamoDB requests, like all CRUD operations. It also should be able to cache things to avoid like if the query already, like if the request already got to the service by some reason, but you have the cached values, still, even the service got the request, there is no reason to bother DynamoDB, because it's, after all, it's another like cent, like not cent, like another dollar, let's call it so. But if you think about the very big scale, like when you have millions, tens of millions of users, if something won't be covered, it could cost you a lot. So I would prefer using caching rather than avoiding using it, and to save some money over here. We need to have a proper error handler. That's why I mentioned 4 of them. And maybe someone won't like it, but I did it. And the 2 things that I didn't mention here is like, you need to have throttling mechanism and rate limiter. Actually, it depends. I mean, it could be done on the, it should be done also on the service side, because like services, like let's say it's standalone thing, but you also may think about like throttling on the clients. So I mean, throttling for sure, and rate limiter is one. Since we're talking about the service already, is 2 things are very important to have in your services like that. So don't forget to cover it. And I think that's actually it. Yeah, that's it. And I think you did it faster, you know. If you have any questions, just let me know. I would be happy to answer them again. If not, thanks for listening. I hope it was interesting to you, and will give you some ideas maybe, or you will decide to do something similar to this. Just let me know.
Well, thank you for the presentation. If anyone has any more questions, that would be a good idea to ask now. If not, then thank you very much for giving this presentation and for being here, and for those who were watching it live. Now you have the chance, so I'm telling it also to the viewers on YouTube channel, that those people who are here in the live meeting, they can stay on, and after we stop the recording, we can open the mics, and then we can have a conversation, asking all kind of other questions that you might have not wanted to do be on the video. So anyway, thank you for being here. Thank you for watching. And don't forget to like the video and follow the channel. And see you next time in the next, and join the meetup group if you're not there yet. Thank you, and bye bye.
Thank you, everyone.